Hi guys, so let's talk about free response question 1986. Let's start with part A. It gives us these three compounds and says that these are volatile compounds. Each contains this element Q that we're interested in. The percent by weight of each element Q was determined from the following data obtained. So we have the percent of Q in each of these three compounds, and we have the molecular weight of two of them. The first question asks, is the vapor density of X is 27 at 27 degrees, so I have a temperature equals 27 plus 273, which is going to equal 300 Kelvin. That would have a decimal point. And the pressure is 750 over 760, and that would be ATM. I want to go ahead and convert that because I want it in the units that my R constant is going to be in. And it tells me that it was determined, its density was determined to be, so density equals 3.53 grams per liter. And so this looks to me like, and that's a little out of focus, isn't it? This looks to me like we're going to have to use Mr. Polk eats dirt. So molar mass is equal to pressure RT, right? Density. Because we want to find out the molecular weight. And if we remember, molar mass is equal to grams per mole. I have grams here. I want to basically find the moles from here, and then if I took moles per grams per mole, then I could get my molar mass. So if you're ever not sure, I don't have this right. Mr. Polk, I need the P over here. Mr. Polk eats DRT. And I want M by itself, so M is going to equal DRT over P. This is density, the gas constant, temperature, and pressure. And if you ever think you have the equation wrong, you can always look at those units. If it's not coming out to the right unit, you've made a mistake. So density is 3.53 grams per liter. The gas law constant is 0.08206 liters times atmospheres per mole times Kelvin. Temperature is 300 K. And the pressure is, I'm going to go ahead and just divide this out. 750 divided by 760 equals 0.987 ATM. I'm going to use that whole number, but I just rounded it here. So let's look at our units and see if they all cancel. So Kelvins cancel, ATM cancel, liters cancel, and I'm coming out in grams per mole, which is what I want. So I'm in good shape. And so I've got 3.53 times 0.08206 times 300 divided by, and second answer equals. And I get that its molar mass is 88.06 grams per mole, which I would report as 88.1 grams per mole. So I've got the molar mass. Now I know this is kind of small, and you can look this up in your sheet. B, determine the mass of element Q contained in 1 mole of each of the three compounds. So now that I have this number, it's going to make it easier, right? So B. And B says, I want to find the percent of Q in the compound, I can convert that to grams. If I just assume a 100 gram sample, that means I have 64.8 grams in 100 grams of that compound. And if I then take care of the units in terms of molar mass, I can get how many moles I have in that compound. And it's asked me to determine the mass of element Q contained in 1 mole. So if I have 1 mole of the compound, then that would be compound X, let's say, right? Then it would be 1 mole is 88.06 grams. And then I have 64.8 grams of element Q in 100 grams of the compound. Now let's see if my units work. This is grams. Oh, I've got this upside down, don't I? Because this, and that's why we need to label everything, right? This is in 86 grams of the compound. And then in 100 grams of the compound, I have 64.8 grams of element Q. I hope that makes sense to you guys. And so the compound is actually X, right? So I'm going to start with 88.06 times 64.8 divided by 100 equals, I have 57.1 grams of Q in compound X. You're going to repeat that process for each element. I'm going to pause the video for a second, go ahead and do that, and then we'll go on to part C. I don't think you need to watch me doing each individual one. I'll have it all set up when you come back. Okay, so I've gone ahead and done the other 2, and I get these 3 answers. So pretty straightforward, the same exact process, just changed it to the different molar masses and the different percentages. So part C says, calculate the most probable value of the atomic weight of element Q. So they have to be ratios of each other. They can't be odd numbers. And if we look at these, and I think there's a multiple choice question like this too. This is 2 times 19. That looks to me like, let's see, let's take 75.9 and divide it by 19, and I get roughly 4. This is roughly 2, and that looks like roughly 3. So it looks to be that the molar mass is going to be half of this, which would be 19. How would you write it? You know, I don't think you have to give any big definition here. I would just say that 38 divided by 19 equals 2, 76 divided by 19 equals 4, and 58 divided by 19 equals 3. So, this is for part C. So, molar weight, molecular weight equals 19 grams per mole for element Q. Next, it's going to probably ask me, what element is this? And then it says compound Z contains carbon, hydrogen, and element Q. When 1 gram of the compound is oxidized, and all of the carbon and hydrogen were converted to oxides. 1.37 gram of carbon dioxide and 0.281 grams of water were produced. Determine the most probable molecular formula. So I'll just turn this over and start this out. So whenever you have one of these